Welcome back. Today is day 2 of our angles relationship unit. We will define two key angle pairs that we will be working with the remainder of this unit. Hope you enjoy the video. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Do now. So it says warm up. Consider line AB. So we have line AB. I see that. Here's line AB. So consider we have line AB and line CD. So I see line CD over here. Consider that those lines intersect at point E. So perfect. So we have, that's all we have so far. It says, what is the sum? Remember the sum is going to be an addition. So what is the sum? What are these things going to add up to? So what is the measure? Well, we're really trying to find out what is the measure of AEC plus the measure of angle CEB. So first thing I would do is I would identify those. Let's see, because I want to find out what they add up to. So let's identify where are those angles. So the first angle, so the measure of angle AEC. So AEC is going to be this blue angle. So this angle over here. So we want to know what is that angle with, let's use this magenta color, the measure of angle CEB. So CEB is going to be this angle right next to it, right here. So let's do this angle. So what do these two angles add up to? And again, there's a couple ways you can do this. If you know your definitions, that's great. But let me show you an interesting way one of my students did it the other day. So the other day, one of my students said, well, this kind of looks like a complete circle. And I was like, oh, really? Okay, so then what does that tell you? And they're all, well, we know the angles, the interior angles, if we added all four of those angles, they should equal 360 because that's what a whole circle will be. But then they see this line here and they're like, looks like a diameter. It's going to cut the circle in half. So what that tells me is that the top portion would be 180 degrees and the bottom portion would be 180 degrees. And I was like, that's excellent reasoning. So these two angles, they know, should add up to 180 degrees. And there's your answer for this problem. So again, great reasoning by this student who did it this way. But another way they can say, a lot of people will say, well, we know that a straight line, a straight angle, if we just have a straight angle, one angle like this, they know that should be 180 degrees. And also they kind of see the same thing. It's like almost like half a circle. If you take the other side, it's the other side of the circle. So great reasoning, great job on that one. Postulates. Oh, we have a postulate we're going to learn, and we're going to learn what some vertical angles are. So a postulate, and we'll talk about what a postulate is in our next lesson. So right now, let's just go with this linear pair postulate. What is that? It says if two angles form a linear pair. So what does that mean if two angles? Well, pair is going to mean two, so we should know that. That's pair is going to mean two, and then linear just looks like a line. So what we're looking for is really two angles that form a line. So think about what that's going to look like. So what that's going to look like is, here's a line, and we need two angles to create this line. So I can draw any kind of picture in here, and this would be like the first angle, and this would be like the second angle. So now guess what? We have two angles, and they form a line. They make one line together. All right, so what do we know about those? So it says if two angles form a line, then the angles are supplementary. Now recall what we mean by supplementary. Think back to our definitions before. We know that means they're going to add up to 180. So we need to have two angles that add up to 180. So guess what? The formula, the rule we're going to use for this one is the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And that's basically what we just saw on our warm-up, right? We kind of just concluded that from our warm-up. It's almost like half a circle. These two angles make the line. If we continued all the way across, we can make like a full circle. So again, the same idea, but what we call that, we have a name for it. It's the linear pair postulate. All right, and again, I mentioned before, we'll talk about postulate as we go on. So let's look at the next problem. So here's our problem. It says find the measure of angle B. So these shouldn't be too tough. But the first thing you should notice as you look at this, I see 4 different angles in here. I see, an angle here. I see another angle over here. I see this one. Let me draw some circles in there. That'll make it look a little better. So I see an angle here, I see an angle here, I see an angle here, I see an angle here. So I see really 4 angles being created here. But the 2 that are important to me are the top 2, or these ones right here. So these 2 are important to me because guess what? These 2 angles form a line. If I was to take a look at them, these 2 right here form one line. So guess what? What do we know about those? They are supplementary, so they have to add up to 180 degrees. So in this problem, you can do a little algebra if you like. B plus 43 has to equal 180. So together, those have to add up to 180. So what does B have to be? All right, do a little mental math, but B is going to have to be in this problem. What is that going to be? 137, I believe. 137 degrees. Perfect. So guess what? This angle B right here is 137 degrees. And that's it. And we did that by using the linear pair postulate. We know that those 2 angles, since they create a linear pair, they have to add up to 180. And now a lot of students have trouble when the images get rotated. So, but this is the same exact problem. So if you look over here, here's a line, and these 2 angles together create a line, so these 2 are going to have to be supplementary. So this is the exact same problem, but it's been rotated over a little bit. So what do we know about these ones? We know that B plus 63 has to equal 180 because they are going to be supplementary, so then B must be. In this problem, what is that going to be? Mental math again, 117, I believe. Hopefully my mental math is still good. And let's try a couple more. So I have a couple more problems just to kind of get the hang of this, but let's look at this problem. Again, I see a linear pair. I know that these 2 are going to have to add up to 180. So in this problem, guess what? B is going to be, what is that, 125. All right. And in this problem, same thing. There's a linear pair there. So what do we know about B? B is going to have to be equal to, what is that? We need 47, I believe. Okay, so hopefully I didn't make a mistake on my mental math there. But together, those have to add up to 180. Okay, perfect. So that's how we're going to be using the linear pair postulate. Definition, vertical angles. And again, they're related really close to the linear pairs that we just talked about. So 2 angles, let's see if we can decompose this definition. 2 angles are vertical angles if their sides form 2 pairs of opposite rays. Well, first of all, the kind of part that's confusing to me is opposite rays. So let's see what those are. What are opposite rays? So we should know what a ray is. Here's a ray. Let me draw a ray. A ray is going to have a starting point, and then it goes on forever in one direction. So that's what a ray is. Now an opposite ray, so the opposite ray is going to be the ones that it goes in the opposite direction. So all we're going to do is I'm going to draw with another color the opposite ray. So the opposite ray is going to be the same ray but going in the other direction. So we start at the same place. So these right here are what we call, these are opposite and rays. Okay, so let's see if we can now let's see if we understand that definition now. It says 2 angles, so we're going to need 2 angles, okay? And they are vertical angles if their sides form 2 pairs of opposite rays. So let me see if we can understand this. Let me draw one angle. So I'm going to draw one angle. So here's an angle. All right, so that's an angle. All right, and let's call this angle 1. Or let's call this, let's call this angle, let's call it angle A. All right, so there's angle A. Now, this other angle has to have, is the sides are formed by opposite rays. So now I'm going to draw opposite rays. So I'm going to take one of these rays and I'm going to make an opposite ray. And what do you notice what happens when I create an opposite ray? Every time it's going to create straight lines. So here we go. So I just created the opposite ray for the first one, and then I'll make an opposite ray for the other one. And now this looks almost exactly like your picture. And now I have, in this problem, I have 4 angles there. I have 4 pairs of angles. There's this angle, this one, and this one. So in this picture here, which ones are the opposite rays? Well, they're the ones that make up the same color. So again, in this problem, I'm going to label these right here, this is B. A and B are opposite rays. And another way to think about it is they're really like across from each other. So a lot of people just use that, the ones across from each other. If you make an X and you go across from each other, those are vertical angles. But the definition, that's what the definition was saying. So what we should know about this problem, let me draw a picture. So here, let's draw pictures for our notes. So really, it's basically we're drawing an X, and let's label these A, B, C, and D, and let's write this out. Angle A and angle C, the one across from it, are vertical angles. So I'm going to circle those. So angle A, so this one and this one, these are vertical angles. Now there's another pair of vertical angles also in this picture, so I'll write it with another color. So in this same picture, angle B and angle D are vertical angles. So we actually have two pairs of vertical angles in this picture right here. So that's going to be these ones that are across from each other, okay? And we're going to learn some more about those things as we get going, but I just want to go over the vocab today. So now that we know, we kind of got some things going on here. So let's go backwards a little bit. So now let's go backwards and let's take a look at this, and maybe you'll start noticing things. All right. So real quick here, one thing that I'm going to want to do is see if we can figure out what is the measure of the angles that are missing. So when I look at this picture, let's go back to this first problem. Can we find this angle right here, the one that we're missing? Well, we said that the one next to it was 137. So again, if I look at this again, these are also a linear pair. So these two right here form a linear pair. And if you do a little subtraction, you'll find out that this angle is 43 degrees. So that angle is 43 degrees. You're like, what the heck? Check it real quick. And then if you notice also on the other side of the problem here, we have another angle, this other angle over here, the one that's missing. If we use like these two together, these two right here make a linear pair. So we can do a little subtraction from 180 degrees and we'll find out that this is 137 degrees. So take a look at that. So that's kind of interesting. So in this problem, hopefully you're starting to see something, because again, this is what we're going to be proving in the next couple of days, and we're going to be learning this. But what do you notice about those vertical angles? This is 137, and the vertical angle, the one across from it, is 137. And take a look at the other ones. This is 43, and the one across from that one is 43 also. So it looks like in our problem, it looks like vertical angles, we could write it down after this, but we're going to end up proving this in the next couple of days. So what I see here, let's try the next problem. If this angle is 63 and we go across from it, what is the vertical angle? The one that's across from it, that's going to be 63 also. We already knew that this one was 117, so guess what? Across from that, it's going to be 117 also. So vertical angles are really cool because what do you notice? They're just equal to each other. So I could do the next problems really quickly. So if that's a 55 degrees, this one is 55 degrees. If this is 125, we've already said that, then this one's going to be 125. So vertical angles are real nice. So we got 133, and we got next to that 47. So let's add this to our notes. We're going to prove it in the next couple of days, but let's add that to our vertical angles. Let's make a little note here. I'll put a star here. Vertical angles are equal. Okay, we're going to prove that actually. We're going to actually show, we're going to do a little proof of that in the next couple of days, but that's the main idea. So again, you'll be solving problems with vertical angles and linear pairs, and you need to know the two relationships. So recall what we just said right now, linear pairs we learned from earlier. We know linear pairs are supplementary, so if they form a line, they have to add up to 180. and if they're basically across from each other, if they're vertical angles, they're going to be equal to each other. All right, so let's try some algebra problems. So let's try to solve these problems. So again, these are going to be a little bit more difficult because we're trying to solve for x. But what I really want you to focus on is what is the relationship, and really being able to write in the relationship with symbols in algebra. So in this problem, when I look at the first set right here, what do I notice about these two? So first thing I notice that these two form a linear pair. So the 38 degrees and this angle that says 5x plus 2 form a linear pair. All right, so that's the key right there. So now I'm like, okay, that forms a linear pair. Now I need to think, what relationship do I know about linear pairs? Well, linear pairs are supplementary, meaning that they add up to 180. So what I should be able to do right now is just write an equation. So 5x plus 2 plus 38 is equal to 180 degrees. And there's my equation. Now guess what? I can solve for x. And all I did to know that was really know the relationship between those two angles. Those two angles are supplementary because they're linear pairs. All right, and then I would solve that. I'm going to solve it quickly with GeoGebra in a second, and then I'll do it by hand. But I want to show you real quick, if you're struggling with algebra, you can still use technology to help you solve equations. So now in the second problem, what I notice is that these two angles here, these two form vertical angles. So take a look. So again, remember, like if we draw an X, there we go, we have an X there. Those two are across from each other. So what did we say today? We said, oh, well, it looks like those are, well, first of all, they're called vertical angles, but we said they're equal to each other. So now how do we write that relationship? And I know a lot of students have trouble writing equations because they're not used to writing relationships out. So what's the relationship between those two angles? They're equal to each other. So then I just have to write an equation saying that these two things are equal to each other. So in this problem, I would say 5 plus 6x equals 53, and that's it. And then I can solve all kinds of problems just like this. So let's take a look at GeoGebra. Let's see if I can memorize what I'm doing here. 5x plus 2 plus 38 equals 180. All right, let's solve these problems really quick. So again, remember, you can just solve equations using GeoGebra real quick by just writing the word solve, and in parentheses, let's type your equation. 5x plus 2 plus 38 is equal to 180, and I'm done. Answer is 28. Man, I am so fast at these. Let's try another one. Solve. The second problem we had was 5 plus 6x is equal to 53. And that answer is 8. So let's take a quick look. There's both of my equations solved. So again, if you're having trouble, you can still use this to help you solve these problems. But we'll do it by hand now, just in case. Okay, so now that you've seen how to solve it, let's solve it by hand. So again, if you like traditional, let's manipulate this by hand. Let's go ahead and do this. So this would be 5x plus 40 is equal to 180 degrees. Subtract 40 from both sides, so 5x is equal to 140, and divide both sides by 5. Let's see, what is that going to be? 28, I believe. 28. All right, so again, that's how you would solve it by hand. Let's try the next problem. So that would be the answer for the first one. I'm going to subtract 5 from both sides of my equation, so this will be 6x is equal to, what is that, 48? Oh, this is a nice one. So x is equal to 8. All right, so that's how you solve it by hand. But again, if you really struggle with, and then when we start doing harder problems too, again, I'm going to want you to use technology sometimes to do it too. All right, hope this helps, and check out these next problems just to see if you understand what's going on. Oh, maybe I'll have to do it again later.